Thanks everybody for coming here. Mark would talk about our MCP server. I think one of the most exciting things that we've done recently.
Welcome, everyone. Today, we're going to talk about how we're connecting EdgeLake Edge data directly via MCP so that you can run AI against that data while it still remains at the edge. EdgeLake is an edge native data fabric. The most important things we'll discuss here is leaving that data at the edge, but yet giving it the power of AI analysis without having to move the data anywhere. So this is a standard antitrust policy notice. If you've got any questions, please look at the Linux Foundation's antitrust policy. So what's happening in the world? Today, we're going to talk primarily around industrial data, but what's happening at the edge is that more and more data is being collected from instrumentations, PLCs, machines, and other devices. That data is exploding. And to get analysis of that data, to gain insight to that data, what companies are having to do, are forced to do, is centralize it so they can run deeper analysis, do dashboarding, and other items of that data. One of the other challenges of moving data for that centralization is that I lose control. I don't no longer own the data. I'm giving control of that data to someone else, like an AWS or Google or an Azure. Many manufacturers, especially in the automotive industry, have problems with that. For example, Ford will not send their data to anything in the cloud. That data is considered very important to them. So they are building data centers just to host their manufacturing data so they can run the analysis internally without having to send it to something in the cloud. Those are big costs, whether I'm building a data center, or whether I'm using Google, or whether I'm using Azure or AWS. The more data I send, the more cost it is. So I'm getting a huge cost now as I ship my data to the cloud or to a data center. EdgeLake simplifies this process. And how it does it is that effectively it leaves the data at the edge. It doesn't move it anywhere. It stays close to where the real-time data is being generated from sensors and PLCs and other industrial processes. But what it does, it provides a virtual data fabric. And that virtual data fabric allows that data on many different edge nodes to look as one common database. I don't need to know where the data is. I don't need to know what the data is. It gives me one interface to access any of the data being stored at the edge. The nice thing about AnyLog, it's a software agent that you deploy on an edge compute node. And that software agent is connected to southbound devices. We're going to show an example of that today, like a PLC. And once that data is ingested from the southbound devices, AnyLog takes over data management. It automatically creates tables and structures in an automated fashion, so I don't need to have DBAs or engineers needing to create data tables and manage these complex data structures. AnyLog handles that for you. Most importantly, there's no real-time lag, right? As data flows in real time, I don't have to move it across a network to a cloud. I'm moving it basically to local storage close to where the data is generated. EdgeLake will also offer encryption. So there's a security component to how data is accessed and who can access data and who can see data. AI brings new challenges. We talked about this a little bit earlier. We're having to build huge cloud data centers to host this data so I can run deeper AI and analysis on that data. I lose real time to a lot of that data. What tends to happen is because of the volume of data at the edge, I tend to push summaries of data into the cloud so I can run the analysis. That summary is nice, but it loses the fine-grained resolution that you might need to diagnose issues or problems at the edge. And obviously, because of complexity of data, Every PLC is different. Every PLC is programmed differently. There's tens of hundreds of different types of PLCs out there. All of that data becomes in different formats. So it becomes difficult to kind of gather that data and get analysis of it. Somebody has to transform the data. AnyLog or EdgeLake will help with that because it understands that, and you can leverage the AI to now with the transformation at the edge instead of having to transform it once you get it to the cloud. EdgeLake lowers the center of gravity for AI. Because of the way it works, data sits at the edge. Instead of shipping all that data to do your AI aggregation and training, what we offer the ability to do is we push the queries down to the edge nodes, and the edge nodes query the data, execute the query on the node, and return back the aggregated data from all the nodes. The other nice thing about that is if I want to run an inference or a training on that data, I can access the data completely at the edge and not have to ship it all to run inferencing and training. This is a game changer for high-speed analytics. So now I can access the data on a single node, or I can access the data on all the nodes in the same exact process. We're going to talk a little bit today. We're going to show how EdgeLake is connecting to an LLM. And the example we're going to use today is Claude. LLMs gives us the ability to process large volumes of data and help us make better decisions on what the data is telling us. The problem with LLMs is it needs a common place to look for data. So that typically means cloud or data centers. What we're bringing with this, and we'll talk about it in just a second, is a new methodology of where I can use LLMs, but connect directly to the edge data without having to centralize it. EdgeLake is offering an MCP, a model content protocol. It's an industry standard way of connecting to agentic AI. EdgeLake has just introduced or is about to introduce an MCP to connect to the Edge Data Fabric. So now I can connect up any agentic AI or LLM and directly access the data at the edge and do analysis on it without having to centralize it. Any questions on what we're doing with the MCP?
Mark, so just to clarify, so the MCP is what? It's a script, it's a server, it's something that is inside the LLM. Where does it really resides?
So the MCP is a service that runs on what we call a query node. A query node is a node we use to aggregate data from all the data stored at the edge. So when I issue a query to a query node, I now can connect to that same node via an MCP. So it acts like a distributed query mechanism. All right, I'm going to switch over to a live demo now.
Before you switch over to a live demo, I have a quick question. From what you've just said, I see this as something that collects data, stores data, indexes, queries from a distributed set of end nodes, and acts like a decentralized database layer, not a private tool or a privacy tool.
So EdgeLake or AnyLog has the ability to secure that data at the edge. So I can secure with certificates. I can secure with encryption as the data flows across the network. I can assign users to access certain pieces of data in the platform. So there is typical standard database type security in the product, but it doesn't provide, I don't know if I would call it privacy. We could work with databases that can do encryption at the edge in the database itself, but that's a pretty hefty price to pay if you're pulling in real-time data.
Okay, so now I have two questions now then, after that. This does not, or does it optimize IoT data?
What do you mean by optimize?
Well, you're taking data from the edge. So you're
Yes,
running some sort of analytics at the edge. You're leaving the primary data there, so you're only sending the results opposed to backhauling all the data and
correct.
analyzing either at a on-prem or in a cloud situation. My thoughts here are, if you're only taking the coefficients based upon a defined algorithm, whatever that may be, third party, can you optimize data pipes, number one? And can you, based upon either encryption or non-encryption, and given that it's now non-reference to a work function like a PLC, can you send it to a cloud and forego that forward data sovereignty, if you will, from a reference you made earlier?
Yeah, so that's what's really important here is because I leave the data at the edge, data sovereignty becomes less of an issue. The data is in the secured place where it belongs, and only queries can come in from the cloud if they need to get it and request that data. But again, it would have to have permissions to do so.
Okay. And my other question, thank you for that. And my other question is, you mentioned that this is real time. So does that imply that Anylog is not storing any data?
No, it stores the data, stores it to a local database on whatever edge compute node is there.
Thank you.
Great
If I
question.
if I can step in, one of the advantages here is typically you would ask, so the data is distributed on multiple servers, but the thing here now is that rather than having an interface just with SQL or REST, you can now ask an LLM a question about your data. You don't have to know the topology of this data or what the database tables are. And we built this MCP server that's embedded inside inside EdgeLake, and it allows you now to ask questions, and the LLM will service the request for you on your behalf and tailor that query based on the data that it sees. So now you don't need a BI tools, and you don't need data scientists to analyze the data that's being generated in real time.
Okay, thank you.
Sorry, Mark. I want to add just two short comments on Pritu's question. One about the security. So the assumption is that your edge nodes is on-prem, so you have full control of them. It could be inside your firewall, or it doesn't change. I mean, that's the way it works today. And the data on transit were queries that go to the edges and result sets that move to the applications. They could be secure. That's easy. The mechanisms are there, so you could encrypt them. So it's much more secure than taking your data and placing it on a third-party cloud or a data center. Then for the real time, you've got logic on each one of those nodes, and the logic could act on streaming data that comes in to the node. So immediately as data appears on the node, it could be processed, and you could put rules and alerts on it. And at the same time, we keep the history of the data in a database, so you could also act on historical data, which replaces the need to have all the data moved to the cloud and be kept there on big and expensive databases, and obviously takes away the need to move all the data to the centralized location.
Is that helpful?
Yes, thank you.
So what I wanted to show in this example, I've got an MQTT broker that's receiving data directly from a PLC. This PLC is actually controlling a pharmaceutical plant. So it's a batch processing. So you could see in this MQTT Explorer here that I've got live data coming in from the PLC. For EdgeLake, all I've done is subscribed to this PLC via MQTT. That's it. That's all I've done. I set a southbound connection to say subscribe to this topic and collect data. AnyLog EdgeLake sees that data and automatically creates data tables out of that data and starts storing it. That easy, that quickly. It's literally about a 5-minute process to do that. Once that data starts flowing into the environment, we can now connect up our LLM. In this case, I'm using Claude. And I've already pre-run some of these. Claude can get slow at times, so I I ran some of these already, so we can see the types of analysis you could do to data very quickly once it flows into the EdgeLake system. So the first thing I asked the data is show me the architecture of the system that's collecting the data. And it shows that it's got 2 operator nodes and a master node. So as a brief description, an operator node in the EdgeLake parlance or vernacular means that it's a node collecting and storing data at the edge. The master node acts as a coordination layer. It really is a blockchain emulator. You could actually use a real blockchain in this case, but most of our customers, at least early on, have been using a master node to emulate the blockchain. We use the blockchain to actually coordinate metadata between all of the nodes. Policy data. In manufacturing space, they have something called unified namespace. That data, instead of having to store it in tables, we store as metadata, and then that metadata is shared amongst all of the different devices collecting it. So I said, now show me a diagram of that same architecture. And it literally draws out the architecture where we're collecting data, what data is being collected at each site, and the master node. The next thing I said was show me the tables that's being collected. And so it begins looking at the data and says, okay, here are temperature controllers. Now, again, I never told this data that it was a temperature controller. This is inferred by the LLM itself. But from the names of the tags that are coming in from the PLC, it's split up into temperature controllers, flow controllers, speed and agitation controllers, analytical instruments, pressure, valves, and weight. All of that was inferred automatically just by pulling in the tag data from the PLC. As a former industrial controls person, this is, I was dumbfounded at some of the analysis you could get from that.
And Mark, I think it's also important to mention, because we look at the streams of data coming in, this is analysis on live data. Obviously, you could tell Claude, look at the history, what happened yesterday between 2 and 4, but obviously at the same time, in the same effort, he looks at live data that streams in.
Yeah, this is running against live data at the edge, right? There's no centralized data here. It's all being collected at the edge. The next thing I asked is show and graph a unified name structure for the data. And what's interesting is it understands the data structure as it's coming in and actually starts creating a unified name structure for it. So if I bring it up, you could start to see that the name structure for Unit 250 bioreactor, again, this is all inferred by the process. You could see that we have the status, the start of the process, how much is being manufactured per minute. In site B, we'll see that we're processing a liquid in tanks, and you can see the lot that it's currently processing in the tank and the state, duration, and flow rate. All of this was completely inferred by just pulling in the raw PLC data. Get the right window back. The next question is, I said, create an ISA 95 align.
Sorry, I just got one quick question. Sorry to cut you off there.
No worries.
This is all inferred by the data that is pulled in from the PLCs. This is not including the code, just the data.
There is no code in this.
Okay,
Zero.
perfect.
All it is raw data coming in from PLCs.
Oh, okay, thank you.
Yeah, not a single bit of code has been run. All I did was connect up Claude to the raw data and everything else is being inferred by Claude. The next thing I asked it is, if you notice on the previous slide that there's not a good namespace for this. This is in what's called ISO 95 format. So basically it looks at locations, it looks at processes, it looks at instrumentation, devices, and then instrumentation on that device. That's kind of the ISO 95 methodology. This is already in it. You notice here, it's not. It's just basically PLC tags. So the next thing I asked it to do is create an ISO 95 namespace for unit 250 and generate a graph for showing the calculated namespace. So it goes and uses a standard ISO namespace and generates a structure. And this is the proposed structure. Enterprise C, site manufacturing, unit 250, equipment module, device, then sensor. So it literally pulls that out and generates this unified namespace so it can be useful by human beings and not just a PLC engineer. The next question I asked it is describe the data in the databases. And it describes, the types of data that we're seeing. You notice that it...
Mark, the question is the following. So you confirm you have not done a finished training on Claude. This is the raw Claude from the
This is
internet.
raw Claude. Yeah, zero training. This is just its ability to analyze like data.
And it's important to mention that we support Olama, so you could basically plug any model that you want and run it locally. It doesn't have to be a cloud-based model.
Now, in manufacturing, there's a metric that's extremely important, something called operational equipment effectiveness. It's basically a quality metric. It measures downtime, it measures failures, it measures all of that. It basically says, how efficient is my factory running? If you notice, in the raw data, there was no OEE calculation at all. It was just raw PLC tags. So the next thing I said was calculate OEE for unit 250, site 1, site 2, and site 3, and create a chart. So it goes off, it calculates OEE based on the PLC tags that it sees. It inferred what tags were needed to calculate it and generated a graph. So you could see OEE for bioreactor is 100%. It's running. The cap shack was 88.9%. The filler central plant was 93.8%. And the generic plant was 96.1%. And again, all the Claude did was look at raw metrics coming in from these PLCs and inferred OEE. In manufacturing, people spend tens of thousands, if not hundreds of thousands, to get OEE measurements for their manufacturing. And literally, just by connecting up to an MQTT topic from a PLC, we were able to calculate that in minutes. And the last question I asked it is find me anomalies in the data. So it goes off and finds some anomalies. There's timestamp duplication in the bottle factory. There's extreme temperature anomaly in site 3. You see it spiked to 81.6 and the normal is a 40 degree Celsius. It told me that the lot that was working on is potentially compromised because of that temperature spike. It found pH problems. Told me when the pH problems occurred. Again, temperature variability. So just by asking it a question, it found potential issues that I need to go investigate to see if I've got quality problems for these particular times. And what's interesting is I could say, do this for yesterday at noon, and it would have done the same just on the data that I asked it. So I thought I would run a live query against the system. Does anybody want to give me a query?
Ask him if there was a throughput dip in the production line.
Can you show downtime, Mark? Like, is there downtime?
Now, this may take a few minutes to run. Any other questions while this is processing?
Mark, this is the setup we prepared last night. Let's compare site 10, 1 and 2 for sites 1 through 3 and see what happens. So compare the flow rate for the 3 sites on 2 of the tanks.
Okay. Hold on, it's still processing this one.
Yeah, not a problem. And then we would be showing actually distributed and then drilling down on the unified namespace as well.
Yeah, what Ori is saying is that we added a couple of more MQTT topics for different tanks yesterday. And these are actually being run on multiple edge machines. So it's not one machine, it's multiple edge machines collecting tank data. And we'll do a comparison of that tank data in just a second. It's still crunching the report. Like I said, that's why I pre-ran these. It can take a bit to run.
Whatever. This is so cool.
Yeah,
so cool.
I have to tell you, I had my doubts seriously before I started playing with this, and the insight it gave me to raw PLC tags was unbelievable. I mean, you could create in some cases you can create an entire SCADA system out of this using the live data and raw tags.
Yeah.
It was just, it's unparalleled, the power.
I'm thinking, so you're pulling live PLC data. So let's look at critical infrastructure, right? One of the biggest things with critical infrastructure, say, power company, water and wastewater utilities, whatever.
Yep.
You want to know uptime, downtime. You also want to know pump runs.
Yep.
What's the best way to utilize my energy efficiency, right? This could be huge for that.
Absolutely. As a matter of fact, one of our early customers is exactly that. It's a city in Kansas called Sabetha. And we have connected this to Claude, their data to Claude. And we already had, we asked, I think Moshe did a question a few days ago, find me potential problems in my infrastructure. And it literally spat out a report saying that this generator is operating out of spec and is likely to fail.
That's awesome.
Just by querying the data. Like I said, Claude is not the fastest thing, but it does do a pretty good job.
Yes, Mark, I think there is a very strong value that, a lot of companies, especially cities, they're complaining they will lose some skills when old people retire, and it's scary. How do we keep the skills? And you can actually ask any question about your equipment there. You don't need to, you can learn being an expert by using the tool.
That's valid. That's very valid.
Yeah, it's a huge problem in manufacturing right now, and city is the loss of knowledge. People are retiring and you just don't have the knowledge anymore. This helps augment that knowledge. All right. So here's our downtime analysis for Site 2, Site 3, and Site 1.
I think some people are probably paying millions to get this.
Oh,
Yeah.
yeah, absolutely.
Yeah, the only challenge here is this answers the question of what, but not why.
It's something we could probably ask it and maybe it would tell us. I don't know.
I think, Joe, to your point, I think what we would want to do, I mean, or somebody that takes it, he needs to train a model or bring a trained model, and then he could answer these types of questions.
Or you can just drill down and ask question to your LLM.
Well, this is where we need to digitize the expert's brain.
Yeah. Well, the one thing that you can do with this though is, so you see like Site 1, the Cat Shack, you got total downtime of 17.7 hours. You know that's what you have to, at least now running this, you know that's where you have to
Focus.
focus on. Yeah,
Yeah,
exactly. So
exactly.
then you're gonna go dig into that, and then you can go ahead and ask it. Say, okay, so this pump was down for this long, this pump ran too long. What was the efficiency? I mean, I think this is still, yeah, I mean, you're gonna have why, you're gonna have to find out why for sure, but this is a great start. You know what I mean?
Well, again, I bet if we asked it, because it's got the PLC data, it probably knows why. It's going to say, it's going to say that this valve quit working because I'll see it in the PLC data. So I bet it would help figure out why there was downtime at Cat. We'll ask it in just a minute. Ori wanted me to compare tanks. There's 6 tanks in Site 1, so I'm just running a comparison on the 6 tanks in Site 1.
One comment, you could see that the queries, he runs both queries from the metadata from the blockchain about the structure that EdgeLake was pushing as policies to the blockchain, and at the same time queries to the data, and the combination of those two things allows EdgeLake to figure out what to pull both the structure and the data, so he could make the inference and the decision and the analysis.
All right, so we finished our comparison, and then I'll do the conclusions. 6 tanks. You can see the UNS for each tank. Tank 4 had the highest utilization with 5 lots. Others were balanced at 4 lots. Shows the load distribution, the average lots per tank, average temperature per tank, average flow rate per tank, which lots they processed, and the time it took to process that lot. Make sense? All right, so what's the conclusion? Very simple. Literally, by pulling in raw PLC data, we've got an amazing amount of simplicity. Data is being stored. We've got historical data that's there on that. And then you can use the inference to do really amazing things with manufacturing data or any PLC type of data. Users can drill down at the edges. All you have to do is ask a question and it infers and makes really clear answers. Now, I didn't look at the quality of answers. Some of these reports may be wrong, may be a little off because it is an LLM, but at least it tells me where to point to start to look for issues. And, download EdgeLake. You guys can start playing with this today. Start collecting data. Connect to OPC-UA. Connect to, I think we've got Dynex on the call. Connect to Dynex to go get data from PLCs and have Dynex push that data into AnyLog. It's a very simple process. And once it's there, the connection to the LLM is as simple as setting up Claude to go talk to the MCP, and then you're ready to roll. Well, thank you for your time. If you've got any questions in the future, contact Eric, Moshe, or myself, or Ori, or Roy, and we'll help you get set up and get going.
Mark, thanks a lot. Really great presentation. Thank you, everybody, for being here.
Thank you, Mark. Thank you, guys.